GMS is the premier software solution for MODFLOW modeling. This video shows how MODFLOW models can be created using the conceptual modeling approach, which uses GIS-style feature objects such as points, arcs, and polygons to create a grid-independent model. We start with an imported JPEG image displayed in the background showing our model. We create a new MODFLOW conceptual model, and within the model a new coverage that we'll use for the model boundary. A coverage is like a layer in AutoCAD or theme in ArcGIS. We digitize the model boundary by simply clicking with the mouse. These arcs could also be created from CAD or ArcGIS data. We duplicate the boundary coverage to create a new coverage that we'll use for sources and sinks, and turn on the attributes we need in the coverage. The big lake will be represented as specified head, so we change the arcs to the specified head type. We create arcs for the rivers, and change the arc type to river and enter the same conductance for all of them. River stage and bottom elevation are entered at the nodes, so they will be linearly interpolated along the length of the arc. The clear lake will be modeled using a general head boundary condition. We build polygons from the arcs, change the clear lake polygon type to general head, and enter the head and conductance values. Now we create points for the wells. We want the grid refined around the wells, so we turn on refining and specify the grid cell size. For each well, we specify the pumping rate. The boundary coverage is duplicated again to create a coverage we'll use for recharge. Build the polygon and enter the recharge rate. Another separate coverage is used for hydraulic conductivity. We create 3 zones of hydraulic conductivity using polygons, and enter the hydraulic conductivity for each polygon. One more coverage is used for layer elevations. Now we create a grid frame, automatically fit it to our conceptual model, and then create a grid that is refined around our wells. We create a new MODFLOW simulation and activate the grid cells outside our conceptual model and map our conceptual model to the grid. Symbols appear in the grid cells underneath our conceptual model objects. Starting head wasn't specified in the conceptual model, so we'll enter it on the grid. The MODFLOW top and bottom elevations were mapped from the conceptual model. Our model setup is complete and we're ready to run MODFLOW. We can import the MODFLOW solution and examine the contours of the head solution.